I recently watched your talk you gave at Stanford, which was absolutely mind-blowing. It was amazing. And there's a few things I caught that I'd like to talk to you about. During your talk at Stanford, you mentioned that there were a few things that were pushing down the cost of EV batteries. So there's a few different players and a few different pushes towards the reduction of EV batteries. And as we all know, batteries are the most expensive component of electric cars. So I was wondering, could you expand on that? What exactly are those different forces that are causing the reduction of the costs of electric batteries?
Absolutely. So lithium-ion batteries are anywhere from 25 to 40% of the bill of materials of making an electric vehicle. Far and away the most expensive component in manufacturing EVs. 5 years ago, there were only 2 battery megafactories in the world. And how Benchmark Mineral Intelligence defines megafactory is a lithium-ion battery factory that is capable of producing more than 1 gigawatt hour per year of production. Now, there are 190 different lithium-ion battery megafactories that have been either announced in construction or already in production, with a target capacity of 2.9 terawatt hours of battery cell capacity. My former employer, Tesla, in their battery day 5 weeks ago, talked about how they want to individually, as a company, produce terawatt hour scale battery factories, which is a very impressive thing to see. And the net result of all of these battery factories being built is a steep downward trend in the battery cell production costs over time. In the last 12 years, we've gone from seeing battery cells cost $1,200 to $1,300 per kilowatt hour to produce to now being closer, on average, for the large-scale producers, anywhere from $120 to $130 per kilowatt hour. That's a 10x decrease in just 12 years. The best-in-class battery producers are already producing at less than $100 per kilowatt hour. And once we're at the point that EV makers can consistently access battery cells at less than $100 per kilowatt hour, that's the point at which electric vehicles and internal combustion engine vehicles will start to be very competitive against each other. And the economics will make more sense to buy an EV for all classes of vehicles, not just the classes in which they're sold today.
Who in the world is the largest manufacturer and exporter of batteries? Is it China or the US?
Most of the world's battery cell capacity today is in China, and most of the planned battery cell capacity is also going to be in China. And if you look at the supply chain for batteries, that's also true as well. So the companies that produce cathodes, anodes, lithium, nickel, cobalt chemicals, 60 to 70%, depending on the commodity, of the total market share for those materials is going to be in China by Chinese companies.
And something interesting I caught on during your talk is that a lot of times what is manufactured in China, for example, is not a lot of battery manufacturers that are done in China are not necessarily applicable or usable in the context of electric cars, for the simple reason that there's a very high standard for battery technology. The last thing car companies want, Tesla, Nissan, want is a battery that combusts in the middle of a drive. So is that true that a lot of where does most of the usable batteries for EVs come from?
Generally speaking, there are 3 tiers of battery cells. So the tier 1 are the battery cells that can be used in a Western automotive application. So these are companies like Panasonic, LG Chem, CATL, which recently became a tier 1 manufacturer, Samsung, etc. There are a few companies that are in that upper strata. And then there are tier 2 battery cell manufacturers. And these are battery cell companies that produce for automotive functions in China. There's a clear value differential, not a value differential, a quality differential in the types of battery cells that can be used in the West versus used in China for electric vehicles. And that is driven mostly by policy and by the consumer profile of the person who's using the vehicle. And there are a couple of dozen companies that are in that tier 2. Every other company we classify as being in the tier 3. And so these are companies that are making batteries for applications outside of automotive, for energy storage, for power tools, for consumer electronics, and other forms of energy storage that are not as intensive or have as high a safety, quality, and reliability threshold that electric vehicles do.
So inside of batteries, we all know batteries are made up of a lot of things. There's a lot of chemicals, there's a lot of metals. What in the batteries is the most expensive part of it?
The materials that you use to make the battery cells are the most expensive. So if we were to break that down a little bit further, the materials that are mostly used in the process of making battery cells today, there's a lot of differentiation, but just, to go with an example, let's take a battery cell from Tesla, which is making cells for consumption in the US. It's generally known that they're using what is called an NCA lithium-ion battery. NCA stands for nickel, cobalt, and aluminum. So those are the cathode materials. On the anode side, they're mostly using graphite for the anode. And then, of course, you have lithium, because electricity is generated by the movement of lithium electrons back and forth between discharging and charging from the cathode and the anode. Now, all of these metals and the specialty chemicals of nickel, lithium, cobalt, aluminum, graphite, etc., these are the biggest contributors to the cost of manufacturing a battery cell. Over time, the cost of manufacturing, so the actual assembly cost, has come down because of manufacturing efficiency and scale from the fact that we're building bigger and bigger factories. But the materials themselves still remain the most expensive component because they're usually bought based on market pricing rather than at cost of production.
So then this makes me curious, are those materials finite elements? Do you excavate them from the floor, or can you manufacture something similar in a lab?
The materials that are used for large-scale manufacturing, the process to get them is you start at a mine. I mean, everything that is made of atoms comes from a mine somewhere, right? So nickel mines, cobalt mines, lithium mines, etc. When you have the mined material, you can't just take, for example, lithium directly out of the ground and put it into a battery cell. That's not how it works. There's an intermediate process where you make a specialty chemical out of the metal that comes out of the mine so that it's usable for battery cell manufacturing. Now, once you get it to the point where it's a specialty chemical, then you go through a couple more intermediate steps to put those metals into cathodes or anodes. And then there's a mechanical assembly process where you bring together the cell can, the cathode, the anode, the electrolyte, and the separator, and you put it all together to make the battery cell.
I was asking that because something that really caught my attention that you said in one of your talks, and that is kind of worrying if you ask me, is that with the current supply and demand we are heading towards, how do you say, what's the word? We're going to have more demand than supply for lithium-ion. Is that correct? So
are you talking about...
That's the word. That's the key word, a shortage. We're heading towards a shortage in lithium-ion in the coming decade. Why is that?
The supply chain to make battery cells is very complicated. So like I said, you start with mined materials, then you have specialty chemicals, then you have cathode and anode before you can make cells. At every single step of the supply chain, something could break. So if you stack up what all of the automakers say they're going to do in terms of electric vehicles, and you translate that into battery cells, and you translate that into the quantities of lithium, nickel, and cobalt chemicals that you need, what you find is there is just not enough lithium chemicals, cobalt chemicals, nickel chemicals, cathode chemicals being produced today to meet the expectations of EV makers in the future. So the entire supply chain has to grow along with the automakers who want to put more electric vehicles on the road. And that's going to take billions of dollars of investment all over the world into high-risk projects.
But then this makes me curious because I'm looking at it on the business side of things. Clearly, EVs are the future. So why don't entrepreneurs or investors why aren't they pouring their money into supply chains, knowing
it's
that
important to note what I said earlier, that these are supply chains that are high risk. So first of all, the mine is going to be wherever the mine is, right? It's not going to be like you can make chemicals anywhere. It's just a question of at what cost. You can make cars anywhere. It's just a question of at what cost. But oftentimes what you find with mining is the best resources are in places where attracting financing is difficult and where there is an element of geopolitical risk that can't be discounted. And so that's one of the biggest difficulties in expanding supply chain capacity, is finding projects that are sufficiently de-risked such that they can attract financing at the billion-dollar level that they need them.
But so then what is the potential solution to that if we're clearly heading towards a shortage?
So there's two ways that I think about. There's two ways that I think about it. The first is we should look at extending the life of battery cells that we have on the road now to be as long as possible, so that we put off the need for making new battery cells as much as we can. There's an academic study that was done on the original Tesla Roadsters that showed that after 10 years of use, the average cycle life of those battery cells was about 93%, versus batteries that are only reaching end of life when they're at 80%. Now, those were battery cells that were manufactured in the year 2010. Battery cells that are being manufactured today are going to be at such a sufficiently high quality that they'll probably be able to last for 30 or 40 years before they have to be scrapped for use. And I envision a future in which when you buy an electric vehicle today, after 10 years, you'll hold on to the battery pack and just replace the car body, because there's going to be so much more value in the pack than in the car body. Now, the second way that I would think about this is via battery recycling. So, instead of going out and finding primary materials from a mine, you just reuse the materials that are already out there in retired battery cells that are coming back to you. There are plenty of companies that are working on this now. So J.B. Straubel, who used to be the CTO and founder of Tesla, is now working on a new company called Redwood Materials that is looking at recycling battery cells. There's another company in Canada called Li-Cycle. There's a company in India called Atero. There are plenty of companies in China that are looking at lithium-ion recycling processes. So recycling is becoming a bigger and bigger deal to try to solve this question of how to make up for the lack of primary material availability.
And I'm glad you mentioned recycling, because that was actually one of the questions I had before we move on to the Q&A section, which is, you have a lot of experience with batteries. You know exactly what happens at each and every single stage of a battery's life. So I was wondering, and that's something that was a very common question with our talk with SAS, which is battery recycling. What exactly happens after a battery reaches its end of life in cars? Where is it automatically recycled, usually right now in a factory, or is it disassembled? Where do the chemicals end? Do you reuse them, or do you bury them somewhere deep in the floor?
When a battery reaches end of life in a car, there's two different paths it could go. The first is you could take the battery cell out of the car and downcycle it into a different application. So that means you take the cell and you don't break the cell apart, you just use it for an energy storage application. So one example of this is the Amsterdam Arena. The Amsterdam Arena uses old Nissan Leaf batteries as their backup power to maintain the sort of electricity and power levels for the factory, for the sports stadium, excuse me. There are factories out there that are doing this as well. That's the point I was trying to make. Factories that need backup power to keep continuous operation going, they will use used EV battery cells as that backup power source. The second thing to do is to break that lithium-ion battery apart in either a mechanical or a chemical process. And there's two different chemical processes called pyrometallurgical or hydrometallurgical, where what you're doing, the simplest way to think about it, is to basically break apart the battery cell, and output feeds of lithium chemicals or lithium metal, nickel chemicals or nickel metal, cobalt chemicals or cobalt metal, such that they can then be reused in the process of manufacturing new battery cells.
Okay, that's interesting. Let's go. I hope everyone's taking notes. Whoever's watching this conference, I hope you're all taking notes. So I'm actually looking here at my phone because I'm receiving questions, the best questions we have yet from our admins. So I hope you're ready to move to the Q&A section. Guys, keep bringing the questions because this is really interesting. So we have a question from Stavros that asks, how can we improve the lifespan of batteries or keep their charging capacity to their maximum?
The quality of your battery cell is directly correlated to the quality of the input raw materials. The best thing that you can do to maintain battery life for the long term is to ensure that you have as few impurities as possible in the materials that are used for battery cell manufacturing.
And I guess that brings us back to the 3 tiers.
Yep, that's correct.
So a question from No Name. What will happen if we have a shortage of lithium? It's a good question.
What will we do if we have a shortage of lithium?
Yeah.
Okay, so one of two things will happen.
Actually, what will happen? Yeah.
If there's a shortage of lithium, then we're going to have to try to recycle more. If we can't get more out of mines, then we're going to have to recycle more. Or we're going to have to go find new sources of lithium that are currently uneconomic and make them economic through technology improvements, or the market just has to be willing to pay a higher price for them. Now, if all of those options don't work, like if you can't recycle, you can't access new materials, then we're going to have to contend with the reality that lithium will be the bottleneck in manufacturing new battery cells, and that there will be a shortage as compared to what we would like to see.
Can we expect an increase in EV electric vehicle prices because of this?
Yes, if there's a shortage such that supply doesn't match with demand, prices will automatically shoot up, and that will have a cascading effect through the supply chain, such that the end product, which is the vehicle that's ultimately going to the customer, will cost more to manufacture. It's up to the manufacturer whether or not they want to pass that additional cost on to their customers.
That's interesting. So we have a question by Raj. Is battery weight proportional to efficiency or output power?
Batteries are a dance of optimization amongst many different factors. The height, the width, the weight, the thickness of the wall, the quality of the materials that are used. There are all sorts of numbers that can be optimized. I'm not going to answer your question specifically on weight because I think the broader point is more important, which is if you optimize for lower weight and you're trying to improve that one measure, that means you have to give up on another measure. That means that it's going to have an impact on one of the elements, one of the 3 most important metrics for success on batteries: dollar per kilowatt hour, watt hour per kilogram, and cycle life.
That's really interesting. Mike asks you, what are your thoughts about ultra capacitor batteries made of graphene and with a weight and charge density within a factor of a few of lithium batteries and can be rapidly charged?
What I really like about ultracapacitors is one of the problems that we're going to face for electric vehicles is there's a legitimate argument that is made about how recharging is an impediment for people wanting to buy electric vehicles. So if you go to a gas station with a gas car, it'll take you 5 minutes to fill up your car. versus you cannot fill up your battery pack within 5 minutes because you can't overwhelm the battery pack by just throwing as many electrons as possible at it to make sure that the whole thing gets full within 5 minutes. That's dangerous, and that will degrade the battery faster over time. Ultracapacitors can solve this problem because they can take in a lot of charge very quickly, and they can discharge very quickly as well. Where I see ultracapacitors as potentially playing a role is act as buffering capacity between chargers and the battery pack, such that if you're the consumer and you drive up to a charger, you can charge your capacitor within 5 minutes, and that capacitor slowly trickle charges the battery pack over time, such that you preserve the health of the battery pack while you as the consumer accomplish your objective of charging as quickly as possible, as quickly as an internal combustion engine vehicle car would charge.
Vivas, what is... sorry, what was that keyword again? There's so many stuff. What is an ultracapacitor? Like, for people like me that don't know exactly the definition.
So there are different types of capacitors. There are supercapacitors and ultracapacitors. Okay, they are an energy storage device just like batteries are. Okay, the biggest difference is they have a higher power density and they can accept and discharge electrons a lot faster than batteries can.
Okay. Next question. Will we have a shortage of material used currently in batteries, and do we have replacers? I think that half the question was answered. The second question is, do we have any replacers? So maybe we can...
The one element that cannot be replaced is lithium. Like, it's not a lithium-ion battery without lithium. If there's not enough nickel chemicals for battery manufacturing, you can shift to other chemistries that don't use nickel. Same with cobalt. Same with graphite. There's a lot of innovation now being done with getting rid of graphite in the anodes and moving towards silicon-doped anodes or moving even towards lithium metal anodes. But once again, if you move towards lithium metal anodes, you need lithium. So that's the reason why I'm completely focused on lithium. The shortages in lithium will dictate the growth of this industry.
We got a nice question from Nemanja, who's asking, is production process of lithium-ion batteries polluting environment? By the way, great presenter.
Thank you, Nemanja. I appreciate the compliment. If you look at the carbon footprint of an electric vehicle over the lifetime of the use of that vehicle, it has a lower carbon footprint than an internal combustion engine does. But if you look at just the production process of the electric vehicle, it has 2 times the carbon emissions as an internal combustion engine vehicle's production process. Much of that differential in carbon footprint is due to the battery cell manufacturing process. So the direct answer to your question is yes. The environmental impact of making battery cells can be improved. The reason that it's the case today is because there hasn't really been a mandate to improve battery cell manufacturing. Like, batteries were a relatively small industry up until 5 years ago as compared to what they will be. Now that they're growing exponentially in size, there's just a lot more concern around electricity use, water use, land use, and environmental regulation around battery cells. We do expect that this problem will improve over time.
Ian is asking, is dynamic wireless charging the future for EV?
What do you mean by dynamic wireless charging? Do you mean moving away from moving away from like supercharging or charging stations? Because the answer is that is certainly something that could complement supercharging or something like a charge point or your traditional charger right now. The thing that matters the most is having surface area and having designated spots at which you can do induction charging. I think that it will be a complementary solution rather than being a standalone solution that beats out charging.
Dave is asking you a question I really like, which is, what do you see as the likelihood of a radical battery technology innovation in the next 5 to 10 years? that drastically improve the cell characteristics with long lifespan?
Batteries are technologies that are developed after decades of R&D. So when we see lithium-ion batteries today, we're looking at a technology that's been in commercial use for 30 years. And before that, had 30 years of research and development that went into it. There's no other energy storage technology that can beat lithium-ion batteries in the metrics that matter the most, dollar per kilowatt hour, cycle life, and watt hours per kilogram, and can do so at a large enough scale to rival lithium-ion batteries. And we don't expect that in the next 10 years that's going to happen. Now, that said, something I have my eye on right now is actually hydrogen, because hydrogen does have a significantly higher energy density than lithium-ion batteries. And that is a completely different form of energy generation, distribution, transmission, storage, and use than lithium-ion batteries. So if anything, I don't think a new form of battery is necessarily going to beat out lithium-ion batteries, as much as a new form of energy generation could displace batteries. And I'm not saying I'm betting on hydrogen to win. I'm saying I'm watching hydrogen because I think it's interesting what will happen in that domain.
So a follow-up question, does hydrogen actually solve the problem of chemical shortages?
The companies that are most interested right now in the potential of hydrogen as something that could complement or displace batteries are the oil and gas companies, because they're looking at a future in which, because of increased awareness around climate change and carbon, that their core products use and their core products attractiveness is decreasing over time. These are companies that have done a really good job of extracting hydrocarbons. And they've been very focused on the second part of that, of hydrocarbons. They want to focus more on the first, which is the hydrogen element. Now, these are companies that are experimenting quite a bit in terms of how to best deploy hydrogen for use in automotive functions, in terms of, heating, just electricity use. That's where I would see the most innovation coming from. You wouldn't necessarily think of oil companies as being at the forefront of energy innovation, but in the specific field of hydrogen, I do think that they have an interesting opportunity. The other interesting opportunities that oil and gas companies have is with the battery supply chain. These are companies that have large global footprints, deal with geopolitics all the time, and make specialty chemicals investments for the global energy consumption. We're talking about how there's imminent shortages in the lithium-ion battery supply chain. And so they could fill the funding need, the project management need, and the engineering need that's so badly needed in the lithium-ion battery supply chain today.
Cool. Let's do more questions. So Tilina is asking, how does heat affect battery? EVs like Nissan Leaf like to break down in hot countries.
Yeah. Battery cells are very complicated in terms of, like I said earlier, they're a dance of optimization amongst manufacturers. Standard operating temperature range is one of those factors. And so just as in very hot countries, these battery cells have lots of issues, in very cold countries they do as well. The effective range of an EV in northern Norway is severely diminished as compared to the rest of continental Europe, for example. To answer your question, I would look beyond the battery cell, and I'd look at the battery pack. Now, to go from cell to pack, cells form submodules, which form modules, which form packs. And there's all sorts of elements to go to make the step from cell to pack. There's materials, there's also battery management software. And so to answer your question of how can we make sure that the battery cells survive in these temperature ranges, the battery management system has to be properly equipped to charge and discharge the battery and to keep it within an operating range such that even at high temperatures, the degradation is lowered as much as possible while the customer still gets to drive for as long as they need to. And that is an optimization exercise that will be done by the battery management software.
Nice. And final question by Rohan. The battery swap technology seems to be an alternative solution for time-consuming slow charging. But are EV manufacturers willing to sell vehicles without batteries, as consumer is not the owner of the battery?
One of the geographies in which battery swapping is becoming a really big business model is in Asia, specifically in India and in Southeast Asia. If you look at the customers in India, 80% of consumer vehicles are two-wheelers and three-wheelers. And so it's relatively easy to swap out a battery pack versus if I were to try to swap out the battery pack on my Tesla. I can't do it. It's just too big and too heavy, and I need to actually go to a store to do that for me. Now, also considering how small a two-wheeler is, when I say two-wheeler, I'm talking about like a motorcycle. You can't have a big battery pack on those things. And so by definition, the battery pack is not going to be the most valuable part of the vehicle. The question of value is what's actually going to stop this from being a trend in the West, this being like battery swapping at a large scale for consumer vehicles. Because so much value is in the battery pack, I agree that the customer is not going to want to let go of their battery pack over time. But the world is a big place, and different geographies have different customer profiles and different driving profiles and driving needs. There is a place for swapping in the world, especially in many of these developing countries in Southeast Asia and in India.